Okay, so in this video, we're just going to introduce the double angle formulae. And again, you can see them there. I'll just zoom in a bit for you. Those are the rules as they will appear on your formula sheet. And basically, in this video, I'll just show you where these come from and then how you might use them. And if we just go back to the compound angle formulae, you know that, where are we? Hang on a sec, I'll just flick back so you can see them again. If we just grab one of these, I'll just bring it through for you. Hang on. Here we go. So we'll just stick in here so you can see it. With that compound angle, we were looking at, say, adding to. But what would happen if angle A and B were the same? So, for example, A equals B. Then we would say, well, if we did sine, for example, of A plus A, because that's 2A, we're going to end up with sine of A, cosine of A, plus cosine of A, sine of A. Now those two things are the same, so we'll end up with two lots of sine A, cosine A, which you can see is the first rule up the top there. And we can derive the same from each one just by substituting in an A and an A for the B's for each of those compound angle rules. So that's really where these double angle rules come from. They're nothing new, they are just building on what we already have, but it's kind of interesting to see where it's come from. Now, where these sort of things, what you can do with them, in fact, I'll just clear a bit of space here, is you might get a question, something like, could you rewrite something like this? 2 sine, what have I got, like something like x over 5 cosine of x over 5. And you could just quite easily say, all right, well, actually, I can turn that into sine of, because you can see the angles are the same here, 2 lots of that angle, which is 2x over 5. I mean, it's a very simple application of it. Another one, you might sometimes get something like sine of x over 3 times cosine of x over 3. Now with this one here, you can see it doesn't have the 2 that we have in the rule at the top. So what we know is this is actually the same as half of, if we actually had the 2 there. So it looks like that, which means that I can write that as half of, and then we can simplify it using that first rule, sine of 2a, which will be 2x over 3. So I mean, that's a fairly straightforward example of it, but that's the sort of thing you can do with these double angle rules, is you can sort of, I guess, compress an expression into a simpler term. And obviously you can go the other way as well. If you were given something like, for example, sine of, I don't know, 4x rather, you could then say, well, that's the same as 2 sine 2x cosine 2x. So you can sort of go back and forth, and the way that you go will depend on what identity you're trying to prove. So anyway, that is the double angle formulae, and we'll be using those in some identities shortly.